Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. So moving on, how do we do this on a layer 3 switch? Again, enterprise campuses, large networks use layer 3 switches. We can do this using switch virtual interfaces, SVIs, and essentially we do the same thing, except instead of having to go to a layer 3 router, we can add it to the switch and we can configure the SVIs. And what we do is we go to interface VLAN, type in the interface VLAN that we want, and then from there we can create routable VLANs. Here's an example. We have a layer 3 switch. We have 2 physical ports, gig 106, gig 1018, separate VLANs. So what we would do to configure this appropriately is, first of all, on the layer 3 switch, configure the VLANs, both VLAN 10, VLAN 20. We would create an SVI VLAN interface for both VLAN 10 and VLAN 20. We would assign the appropriate IP address and ensure that they are on. Again, the gateway address of the devices have to match the interface or the SVI on the switch. Next step is on gig 106, we would have to set up port access, switch port mode access, so it's a access port. On gig 1018, we would do the same thing, assigning that to VLAN 20. From there, we would need to enable IP routing, and we do this very easily by, at the global configuration mode, we can issue IP routing command. And this will allow traffic to be exchanged between the VLANs. This allows the switch to actually process the different packets, looking at layer 3 information, and then forwarding it appropriately. If IP routing is not turned on, then this switch will act just a layer 2 switch, only looking at the MAC address and not allowing for inter-VLAN communication. So for inter-VLAN routing using that switch, it's way simpler to configure and makes it kind of nice. Less equipment, but again, the device itself is typically more expensive. If VLANs are to be reachable by other layer 3 devices, they must be advertised using some type of routing functionality. So with that said, turning on routing on a layer 3 switch, then we should be turning on a routed port so that the port can share routed information. And we do this by issuing the no switch port command. We can tell the switch that port gig 0024 is a layer 3 port by issuing no switch port. That forces it to be a routed port. Why would we want to do that? Well, what happens when we want to share routing information? It's a layer 3 device. Yes, it's a switch, but it's a layer 3 device. So to share routing information between that device and another layer 3 device, we could do that. Here we're setting up OSPF, so we're going to set this port right here as a routed port. Again, you'd navigate to it, you would issue the no switch port command, that turns that port into a routed port, and from there you're going to treat that port as a router. You can then configure OSPF so that it knows the networks, and it will use this routed port to send and receive routing updates. How do we do that? Again, configure the routed port using the no switch port command, enable routing, configure the routing protocol, verify routing is there, and then use CCNP. Nice thing is we do have a lab on configuring a layer 3 switch. So moving on, let's talk about troubleshooting. How do we actually go about verifying and troubleshooting inter-VLAN communication? Well, there's typically 4 main areas that troubleshooting takes place when we're dealing with inter-VLAN communication. First of all, missing VLANs. We need to be able to show the VLAN, possibly show VLAN brief, so that we can see what VLANs are there and what interfaces are attached to which VLANs. Keep in mind, it is extremely important. If you configure a VLAN and you configure ports to be in that VLAN and you delete the VLAN, those ports do not magically get put back into the default native VLAN. They are attached to an orphaned VLAN. So you need to understand that. So when you do a show interface and you may not see all the interfaces attached to certain VLANs, that could be because the interface was attached to a VLAN that was then later deleted. So verify interfaces are attached to the correct VLAN and ensure that physical issues, for example, you plug PC1 into port 2 and you configured port 2 to be attached to the correct VLAN. That is one thing that I see quite often. People plug in cables and they didn't configure the correct port, but they plugged in the cable into one port and they configured a different port for that device's access. Moving on, switch port trunk issues. Look at the interfaces. Look at the show interface trunk. Ensure that the trunk is functioning. Ensure that the trunking protocol is there. We use 802.1q. That is not the only trunk port in existence. That's just the one that you learn about through the Cisco Academy, and that's one that's pretty commonly used. Access port issues. Again, you're looking at show interface switch ports, looking at the actual interfaces. You want to make sure that you assign the correct VLANs to the correct access port. If we are looking at inter-VLAN communication, we have to look at the layer 3 devices. Specifically, if we're looking at a layer 3 switch, looking at the SVIs, making sure they're turned on, make sure that the addresses are correct, make sure that the devices have the appropriate default gateway of the SVIs. If we're looking at routers, we have to make sure that we have the correct IPv4 information. We also have to make sure that we have the correct sub-interfaces and that we are encapsulating the correct VLANs. So for example, here we have 3 VLANs, VLAN 10, 20, and 99. We have our sub-interfaces, we have our trunk. We could be looking at the different interfaces to ensure what is there. If here we do a show interface FA06 switch port, we are in the access mode VLAN 10. I'm going to go back. And that should be appropriate. VLAN 10 is attached to on switch 1 F06. But you'll notice here it's inactive. When a VLAN is deleted, any ports associated with that VLAN become inactive. They remain associated with that VLAN, but it's inactive, meaning that VLAN is not present on that switch. We can verify that by doing the appropriate show VLAN commands. We could be looking at switch port trunk issues. We can do that by looking at show interface trunk. It will tell us the mode, the encapsulation, and the status. It will also let us know the native VLAN, and it will say what VLANs are allowed and active. We could be looking at switch port access port issues, and again that could be doing show interface, the appropriate interface switch ports, and from there we could be looking at the access modes, the operational modes, things of that nature. Essentially here we could be doing show VLAN brief, show interface, show running config. All of those things will let us look at the interface to ensure they're attached to the correct VLAN. If we're dealing with layer 3 devices like a router, we would be looking at the interfaces. We want to make sure that one, they're using 802.1q and that they're using the correct VLANs. Did we accidentally fat finger 10 to 100? That's actually one that happens pretty often. We do have a lab troubleshooting. We have a second lab troubleshooting. So we got plenty of practice throughout this module. That's it for this module. We do have a lab challenge and a lab implementation. So what did we learn? We learned how Inter-VLAN communication occurs. Legacy, router on a stick, layer 3 switching. We looked at how to configure router on a stick and layer 3 switching. We looked at the importance of SVIs and them being configured as a default gateway, and we looked at troubleshooting. We looked at a few of the show commands that were there. And that's it for this module. Questions, concerns, please reach out. Thank you.